Welcome everybody to solving quadratic equations by factoring. Before I get into the couple of examples that I'm going to do today, I just want to make sure that we know what a couple things are. And the first thing that I want to list is a quadratic in standard form. And when we solve quadratic equations, we're going to want to put it in this standard form because all of the equations that we're going to use is going to be used from this standard form. So the standard form looks ax squared plus bx plus c equals 0. And this is where a does not equal 0. Okay, so sometimes when we have quadratic problems, we'll have either fractions or the x's on one side or the constants on one side, and we're going to want to put it in this form. The a, b, and c are all going to be constants, and the x is our variable. The next thing I want to be sure that we know what is before we start is the discriminant. You'll find the discriminant in the quadratic formula, what is underneath the square root, and that is the b squared minus 4ac. And when we have our quadratics in standard form, if we put b squared minus 4ac, and if this value is greater than 0, we're going to get two unequal roots. If we get b squared minus 4ac equal to 0, then we're going to get a double root, meaning the same exact root twice. And then b squared minus 4ac less than 0, we're going to get no real solution. Now, of course, when we solve these problems, we're going to figure out whether or not they have two unequals, a double root, or no real solution. But if we want to check before we even start the problem to kind of give us an idea of what our answer is going to be, this is what we're going to use. And then, of course, when we solve quadratics by using the quadratic formula, then you're really going to see this come into play. So let's get right into our first example. Let me switch colors. (6x minus 5 equals 6 over x). Now, starting this problem, much like linear equations, there's a couple things we want to do or a couple things that we want to find out before we even start the problem. And the first thing is going to be list any restrictions. And this just means any value of x in which it'll give us something, an undefined answer. And in this particular case, since x is in the denominator on the right side, x cannot be equal to 0, because if we have a 0 in the denominator, the problem then becomes undefined. So we need to list any restrictions. They're not always going to have any, but sometimes they will. So here x is equal to 0. Number 2, we want to clear the fractions. So we're going to want to clear fractions using least common multiple, and we only have one fraction, that's with x, so the least common multiple of only one value is just going to be the value itself. So this is just going to be x, so we need to multiply the entire equation by x. So 6 multiplied by our 6x minus 5 equals 6 over x. And what that's going to give us when we distribute this x to each of those, we'll get 6x squared minus 5x equals 6. Now this starts to look pretty close to our standard form. Step 3, we're going to put it into standard form. So in order to get this into standard form, we're gonna want to subtract our 6 from both sides, or just move our 6 over to the other side. So we're left with 6x squared minus 5x minus 6 equal to 0. Now we can solve this by factoring. So step number 4, we're going to want to factor. Now here, there's a couple different methods that people use in order to factor quadratics, but for me, this works best. And what I call it is just, factor by what I call the box method. I don't even know if that's a proper term, but that's just, what I call it. How it works is this. When we have our standard form, we're going to list factors of our a value, which is 6. Well, let's put this in a different color. List factors of our a value, list factors of our c value. What we're going to want to do is list our factors in a vertical line. Factors of a are going to go on the left side. Factor of a, and our factor of c is going to go on our right side. And what we're going to want to do is make a box. So factors of 6, well, there's 1 and 6, or there's 3 and 2. So I'm just going to pick a random one. Let's just say what we're going to want to use for factors of a is going to be 3 and 2. So I'm going to write 3 and 2 in a vertical line on the left side. And since we have our same number for c, I'm going to write the same exact thing, 3 and 2. And in order to find out whether or not these are going to be our right expressions, we have to cross multiply with each other. So the 3 times the 2 and the 2 times the 3, well, 3 times 2 is going to be equal to 6, and 2 times 3 is going to be equal to 6. Now what we're trying to find is, can we make some value, can we make a -5 out of these two values that we have here? We have a 6 and a 6. Is it possible to make -5 with these two values? Well, no, it's not. We can either make 6 plus 6, which is 12, or 6 minus 6, which is 0. So we know that this combination of these two factors will not work. So we have to try a different combination. So I'm going to try it one more time on this side. So we'll stick with 3 and 2 on this side. And then instead of writing 3 and 2, I'm going to flip them and write 2 and 3. We're going to cross multiply again. And this time we get 4. And 3 times 3 is 9. Now, can we make a -5 from a 4 and a 9? Well, yes, we can. If we have a +4 and a -9, then that will make a -5. So all we need to do is take our signs, plug them in between our two numbers, and now we have our expressions. So the 3 The x's go with the first column, so 3x, and we put a plus in between here, so 3x plus 2. And then here we have a 2, so 2x. And we have a minus sign in between this, 2x minus 3. And these are our two factors. And once we get our two factors, we are going to use 0 product property. And that is when you set each one of these terms equal to 0 in order to solve for your x. So 3x plus 2 is equal to 0, and 2x minus 3 is equal to 0. For the equation on the left, we'll subtract by 2. Left with 3x equals negative 2. Divide by 3. And we're left with x equals minus 2 over 3. On the right side, we're going to add 3 to both sides. We have 2x equals 3. Divide this by 2. And we're left with x equals 3 over 2. So written as a solution set, negative 2 over 3 and 3 over 2. And our last step, if we want to check our answer, now just going back over to step 1, remember step 1, we found our restrictions. The restriction says x cannot equal 0. Well, we didn't get 0 for one of our answers, so that is good. So that doesn't necessarily apply to this particular problem, the restrictions, because we both got different values in 0. But if we were to actually check our answer, we would get 6, and we would just plug each one of these in here. Negative 2 over 3 minus 5 equals 6 divided by negative 2 over 3. And as long as this checks out, we know that we have the right answer. Moving over to the second example. We have x divided by x minus 2 plus 2 divided by x plus 1 equals 7x plus 1 divided by x squared minus x minus 2. So step number 1, we want to list any restrictions. Well, before we can list the restrictions, we see a quadratic down here in the denominator that we can actually factor. So we're going to just factor this out real quick. I'm just going to write this right next to it. And if we were to factor that out, we're going to get x minus 2, x plus 1. Which you notice that these are the same two expressions that are in these two denominators. So now we simplified this denominator right here. And we look at our denominators, we're going to list any restrictions. Now remember, the denominator cannot equal 0. So x minus 2 cannot equal 0. And x plus 1 cannot equal 0. So that means x can be all values except for when x is positive 2 and when x is equal to negative 1. So those are the two values that will give us a undefined answer, and that's definitely something we cannot have. So step number 2, we want to clear the fractions using least common multiple. Well, we only have 2 expressions that are different in the denominators. We have x minus 2 here, x plus 1 here, and then both of them in this one. So our least common multiple is just going to be the product of these 2 different expressions. So we need to multiply everything by our x minus 2, x plus 1. And I'm just going to rewrite the whole equation right here. And remember, you have to distribute this whole entire thing to each one of these. So here in the first term, we're going to have the x minus 2's are going to cancel. So on top, we're left with x times x plus 1. In the next one, we're going to have the x plus 1's cancel, and we're left with 2 times x minus 2. And over here on the right side, both of these are going to cancel, so we're left with 7x plus 1. Now we need to write this in standard form, but we have some parentheses that we need to get rid of first and some rearranging that we need to do. So 3, we're going to distribute this x, distribute the 2, because we're trying to get this into standard form. So x squared plus x plus 2x minus 4 equals 7x plus 1. Looking at our common terms on the left side, we have an x and a 2x, which gives us 3x total. So x squared plus 3x minus 4 equals 7x plus 1. And remember, we want everything over on the left side and a 0 on the right side. So we need to subtract our 7x. That side's going to cancel. We're going to subtract 7x on this side. X squared minus 4x minus 4 equals positive 1. And now we're going to subtract 1 from both sides. And we're left with x squared minus 4x minus 5 equals 0. So now step 4. Step 4, we need to factor this. Well, we don't have an a here on the left side. So now we just have to find factors of 5 that are going to give us our negative 4. And we know that a negative 5 and a positive 1 will give us our negative 4. Remember, we're only concerned with the factors of the last one. And the only factors they have is a 5 and a 1. So we need a negative 5 and a positive 1. So our 2 are going to be x minus 5, x plus 1 equal to 0. And now we need to use the 0 product property, setting each one of these equal to 0. X minus 5 equals 0. X plus 1 equals 0. So x equals 5. X equals negative 1. So what we have for our two solutions that we got is x equals 5, x equals negative 1. Step 6. And this is why I put this problem into the examples. Check. look at what we had for our restrictions. We had two restrictions here. X cannot equal 2 and x cannot equal -1. But we got -1 as one of our solutions. So we know that this cannot work. Because if we put in this -1 right here, what happens is this denominator becomes 0. And therefore it is then undefined. So even though we got two answers, there's actually only one correct answer, and that is 5. So when you solve these quadratic problems, that is why you need to be sure that you check your restrictions every time, because sometimes you're going to get solutions that look like they're the right answer, but they're actually going to give you an undefined problem, so they're not the right answer. But hope you enjoyed. Don't forget to check out if you need some more help with quadratics. We have quadratic, how to solve quadratic equations by completing the square, and also going to have quadratic equations by using the quadratic formula. But I hope you enjoyed. Please drop a like and subscribe if you're not subscribed. Take it easy. Bye.